The soccer simulation in the video was developed using Unity and C# programming language. This allowed me to quickly create the environment for the agents and then start working on artificial neural networks and genetic algorithm programming. Each player on field has its own artificial neural network. Players are divided in three groups: A, or the players with the verb A on their heads are attack players. D are defense players. G are goalie players. Each group in each team has its own genetic algorithm population in which 100 agents are simulated. Specific tasks was given to each group of players. For attack players it was to follow ball position. For goalie players it was to follow ball position Y. For defense players it was to follow opponent attacker player. Artificial neural network controls player movement on field, ball hit direction and ball hit strength. Goalie players is a little bit special case because his movement on field is only controlled in terms of Y position, because goalie does not need to move across the field. To control these parameters, following neural network structure was created. For goalie players it was 1 hidden layer and 9 neurons in hidden layer. For attack players and defense players it was 2 hidden layers and 8 neurons in hidden layer. Genetic algorithm is used to evolve artificial neural network weights. Within genetic algorithm population, single individual represents a specific artificial neural network, all weights. One genetic algorithm generation is considered to be passed when artificial neural network is updated 4,000 times. Each group of players in algorithm population is rewarded according to their task. When rewarding soccer agents for decreasing ball hit direction error, it was necessary to join this rule with some other rule. For example, in case of attack player, his decrease in ball hit direction error was joined with rule for decreasing distance to ball. If rules were not joined, agents on field will be inactive and more or less stand and just reduce their ball hit direction error, and not working toward accomplishing other rules. So this led to bad overall performance in the simulation and was not desirable. And that's why rules needed to be joined. In final release of the simulation, agents were rewarded as follows. Attack players were rewarded for reducing the ball hit direction error and distance to ball. Defense players were rewarded for reducing ball hit direction error and distance to opponent attacker player. Goalie players were rewarded for reducing ball hit direction error and difference between ball position Y and his position Y. In addition to that, all players were rewarded for increasing ball hit strength, but this parameter was kept so that impossible ball hit strengths does not evolve. Without rewarding agents, they also were punished. All agents were punished for colliding with field border. Goalie players, in addition to that, were also punished if they did not stand in front of their gate. After implementing these conditions, the result in video was achieved, and teams with different generation counts were compared. In comparison, one team had 500 generations and the other had 1000 generations, and to no surprise, team with 1000 generations on average in 10 minutes gained more goals than the team with 500 generations. This condition had a limitation. When team with 1000 generations was evolved up to 3000 generations, it started to play worse than the team with 500 generations, and on average gained less goals and were less active. Reason for this is that at 3000 generations, on average, soccer simulation agent runs into the problem of overfitting. The artificial neural network starts to degrade at his capability to generalize the input information, and so the problem occurs. So that's basically how this project was implemented and created, and that's all I wanted to tell.